Good afternoon, everyone. We're going to wait a few minutes to get started. If you can hear me and you have a live mic, if you could hit mute if the host has not yet done that for us, Jody. Good afternoon, everyone. Just a few more moments as we let people in the waiting room. Glad everyone took a moment out of your busy day to join us, of course. With that, I think we're going to get started. John, give me a head nod if you can hear me. Confirming, yep, John's got me. Okay. Good afternoon, everyone. My name is Russ Gribble. I'm a principal and chief environmental consultant here at United Consulting. We're grateful that you've all taken time out of your busy day to join us. Welcome. For those of you that haven't joined us in the past, we host these educational seminars about every 2 weeks or so, plus or minus a little bit. And we do that both virtually like we're doing today, as well as in person in our Norcross office. If you haven't been, welcome. For those that are recurring, again, thanks for being with us. If I could just for a minute, those that don't know myself and United Consulting, we're a multi-service engineering firm headquartered in Atlanta, or Norcross specifically. And we provide geotechnical, environmental, construction, materials testing, and geophysical services. I think as I look through the list and see some of my friends' faces, I believe most of you already knew that, so I apologize for boring you. I'm really excited about the content today. With us, we have my client, so to speak, and personal friend, Jon Rasmussen. I'm really excited to listen and learn from him today. Jon is a graduate of Auburn University, War Eagle. It's my wife's alma mater. There's no reason with why you're with us, Jon. Jon is not only an exceptional civil engineer, but he is an exceptional athlete, having competed probably in over 100 triathlons in the past decade plus. And his son steals most of his time outside of work, tramping down the soccer field. So Jon is a busy man. He has over 27 years of civil engineering and hydrology experience. After being a partner at a large engineering firm in Birmingham and also a shareholder, he founded his current company known as FloodCon in 2017, where they have over 100 automated products deployed across the Southeast. Jon's a PE, obviously, and he's also a certified professional erosion and sedimentation control and lead accredited professional. My hat's off to this busy man here, sir. Thank you again for being here. Just a few housekeeping items. I will be fielding questions. Please submit your questions through the chat to me, and then I'll feed those back to Jon after his presentation of slides that he's going to share with you all. As we always do, United Consulting does have some giveaways. After this educational event, we'll be drawing randomly 3 $50 gift cards for the Cheesecake Factory. So stick with us to the end, ask some good questions for our guests, and I will announce those winners at the end. With that, Jon, my friend, I'd like to hand the floor over to you. Look forward to your presentation, sir. Thank you.
Thanks, Russ. Thanks for the introduction. Thanks for the opportunity to be here. And Russ reached out to me probably about a couple of months ago and asked me if I'd be willing to talk. And I'm not a very big public speaker by any stretch of the imagination, but I figured, you know with what I do today and with our company, what better way to get some awareness out about our product, but also what I wanted to do is kind of like use what I've seen since I've been doing this new endeavor, if you will, with FloodCon. Kind of like my experience that I've seen on a lot of watersheds as we get new potential projects coming in where I basically take our AOS, design it for the new development or proposed conditions, if you will, to show what kind of a benefit the AOS system, which is an automated outlet control structure, just in case you've never heard of it, and show what kind of positive benefits it is economically most of the time. And so with that, I've become very inundated with a lot of hydrology and watershed analysis. And what I'm going to do today is essentially, and let me really quick, FloodCon we're not a civil site design company. Those folks are my clients. So I used to be kind of a competitor, but now you're my clients if you're a civil engineer. And so that does site development. So what I mean by that is we're kind of like a supplier, kind of, or a product supplier, if you will, kind of like on the lines of, if you have a retaining wall on your project and you need some sort of modular system, you'd reach out to a retaining wall designer or a retaining wall supplier, and they would design the system for you, reinforcement, geogrid, all that stuff. And you would basically sort of like spec it or quasi spec it on the plans. I've been there. I know exactly what CYA means. But nonetheless, that's kind of like what we are, but we're a little bit different because I get really involved with the engineer on the design side of things because, we're designing a stormwater system, and we have to be sure that we meet regulatory as well as the standard of care. So I certified all of our calculations to the design of the system. I provide the material, the documentation to the engineer so that they can submit all of that information with their permit plans, and it goes through construction. So I'm there on the front end through the end of the project, and we continue on because we do a lifetime monitoring of the system. So without spending any more time, I've got a ton of slides. And so I'm going to start sharing my screen. Let's see how this works. Can y'all see my slide?
We cannot yet see that, John.
Well, let's see here. Let me change.
No problem. Take your time, sir. We've got it now, John.
Got it? Can you see it?
Yes, we can see it.
Good.
Hit press your from the beginning slide. It looks like it's not in presentation mode yet, if that's helpful for you, sir.
Oh, okay. Then it's on the wrong. Hold on. I think I've got the wrong share screen on.
That's
So
okay.
I've got 3 monitors, okay? So
Yeah, it's the life of a civil engineer. That's right.
Let's see. I'm going to share screen. It must be screen 1. Share that. And any luck?
Yes, sir. You're good now, John. Thank you.
All right. All right. So I've got about 40 minutes to present about 45 slides. So here we go. The topic of this is going to be basically looking at how we normally take a new development, and the regulations and even the standard of care for the most part requires us to match pre-post peak flows at the property line or at the development extents, wherever it is. Okay, so we think, well, we got a 1 acre site, maybe a little Taco Bell or something like that. Oh, we're just going to match pre-post at the right-of-way line and be done with it. Well, that may be fine and dandy, but when you start adding up 1 acre sites or 5 acre sites or 10, whatever they are, over a larger common watershed, then what happens down at the outlet, say at the 10% mark, or or even less than that. And so what I really wanted to do is take an example and kind of walk you through it as it progresses in new development. And it's a watershed analysis that I've done previously, but we're going to talk about what are the downstream effects from a new development in really what I'm calling pretty much a homogeneous watershed. It's a very rural watershed, which means there's hardly any impervious in it. And so I thought it would be a good one to take at a kind of like at the beginning, or at the, a virgin watershed, if you will, that hasn't been cleared or removed vegetation and stuff like that. So then, do we need to, and while we're going through this, think of these questions. Do we need to normally extend our study downstream? You may have a project that you're dealing with this on right now. And then what information do we have to gather as an engineer to model our system if we need to extend it downstream to a certain point? Obviously now USGS has LiDAR information that's pretty easy. I do it all the time. And if I can do it at 50 years old, I think a lot of the younger guys can do it probably about 5 times as fast and probably more accurate. But nonetheless, you can jump on USGS websites, download cloud data. You can also pull plans, or you can go to Stream Stats on USGS. You can pull some gauge information, see if there is a gauge in the watershed on down, and start seeing if you could kind of, use all this information that's really available to us now to help understand the allowable flows that are occurring downstream of your project site. And then we all use SCS, and we use SCS because it's very, very easy. It's what we've all learned in school. The 484 peak, if you're in Florida, you'll probably use something much less than 484. But, for Georgia and Alabama, Tennessee, 484 is pretty predominant. But then, you also have regression equations out there that, I guess they're somewhere around 30%, 40% accurate. Sometimes they are, sometimes they're not. But what else can we use to check our flows by that SCS gives us on the output side? And that's kind of what I'm getting at. And I've done some interesting things before because I've been taught it. And that is like applying the rational method. I don't know if you've ever converted a curve number to a rational C, but there's ways to do that, and then to come up with intensity, and then come up with a rational peak, and then checking that against your SCS. And I'm just telling you what I've seen. Sometimes I've seen where curve numbers in the 60s and 70s on an SCS are blowing flows out on a outlet pipe downstream of my basin, and I'm like, there's no evidence of overtopping in this road. And even the people on the street, of course, they've never flooded, but nonetheless, they hardly ever see a flood if they have ever. So there's some things like that we can do to attenuate our peak flows by applying what I use is the Clark method, the Clark unit hydrograph. And so anyway, there's other ways to check the SCS flows too. And then what's pre-developed conditions? So we get a piece of property. It may have been cleared 5 years ago. Is that pre-development? I don't know. So you got to look at those kinds of reasonings as you're developing the property by design. And then are pre-development flows at the property proportional to the pre-development flows? 10 times the property area downstream. So with all that said, I think with, we do have a climate change happening. I do believe it to some extent, but I also believe that there's things that we can do as an engineer to help mitigate these circumstances that we're experiencing downstream flooding in a growing rural to urban watershed. And so that's what I'm trying to get, the point I'm getting across today. So this is not a little basin, it's a square mile basin. We actually have an AOS in it. This is Joe Tucker Lake right here. It's Helena, Alabama. And Google Earth, I dated back all the way to the beginning. In 1997, I picked this photo and circled the area where there's most of the intensity in the basin that's occurring as compared to the present photo. And so, you know, like down in here in this area, you look at my cursor, all this is wooded. This was a trailer park. And so now today it's 40 and 50-foot lots, hundreds of lots, no detention. And then you look right here, this is undeveloped. Now it's developed. It's a Walmart neighborhood market with some shops, Mickey D's. And then we have a Publix on the other side right here that used to be woods. And then you have some more development up here that wasn't there. Where is it? Up here? It wasn't there before. You know, so it's growing. It's a growing watershed going, you know, it definitely has some imperviousness in it back in 97. But I guess my question is which is the pre-developed flows? So if you look at it back in 97, you can tell that the flows back in 97 are going to be much different than the flows that are today. And so as your neighbor or your fellow colleague is designing one site, maybe right here, and you've designed this site right here, is your colleague going to say, hey, Clark, how about sending me your plans and your detention pond so I can make sure I meet pre-post at my 10%? Well, nobody says he has to, right? So at any rate, that's the kind of stuff that, you know, happens in a watershed, I think. And we put an AOS in this pond. The city bought and paid for an AOS because we drained the lake ahead of time, because on a 1-inch rain, it was blowing over the emergency spillways, and there was a lot of erosion and downstream flooding on very low storm events. So we drained the pond in advance of a storm to provide more storage. And we also attenuate during the storm itself, because there's about a 45-50 minute lag, if you will, in the peak flow from the peak of the intensity. So here's our example that I'm going to do. It's up in North Jefferson County and kind of in Trussville. It's called Lyles Lane. Lyles Lane is kind of like, this is a HMS watershed analysis that I did. There was a 4 or 5 barrel culvert pipe right here going underneath Lyles Lane that the city wanted to replace. And we had to replace it such that we wouldn't increase or decrease the peak flows or the water surface elevations upstream and downstream of the culvert. So I designed the watershed, also included a HEC-RAS model to check for the flows and the water surface elevations for all the regulatory storm events. But nonetheless, the basin is 1.6 square miles. I've got 14 sub-basins. There's 6 water bodies in it. Slopes are steep, 15 to 30%. It's a rural watershed. It's 3.7% impervious, which, you know, at 3.75, which is the USGS upscale for developed, is 14% developed. Mixture of A-B soil types, curve numbers range from 43 to 65, and TCs go from 12 to 54 minutes. So it's a pretty, it's a homogeneous watershed in the fact that, you know, it's got normal, you know, the slopes are pretty persistent, you know, it's predominantly either pasture or woods. And so I like to pick this watershed overall. And so we replaced the culvert pipe with a RCP, I think 5 60-inch RCPs to match the hydraulics of the old CMP culvert pipes. And so what we're going to do is we're going to look at one of these sub-basins that's about 80 acres in size, and we're going to split it up into 8.08 acres. So basically, I'm trying to meet the 10% on the first one, and then watch what happens as that XB5 grows. And highlighted right there, you'll see sub-basin XB5. And here's the LiDAR map. I just isolated a 10-foot contours. And so you can tell it's pretty the slope on the watershed appear to be fairly consistent. Aerial photo, you'll see a little bit of open space. It's predominantly pasture. Then you have some woods. Existing data is 81.4 acres. I took a curve number of 62.1 and then adjusted it to meet the slope conditions. And I don't know if y'all do that normally or not. I think it's something you do sometimes. Sometimes you may not want to, but in this case, I wanted to mimic what I thought was existing conditions. So I jumped it up, got up to a 66.61. And so there's a combination of woods, impervious area, and pastures. Time of concentration is 23 minutes. I use the lag time based on the slope and the flow length. So on new commercial, what I do is implement an 8.08 acre area. The pre-developed hydrology for that 8.8 acres in this spot right here in the green is all wood. So I threw a 60 on there and of course adjusted it to the slopes. So it came out to be that 64.67. Time of concentration is 10 minutes. And so the new commercial hydrology, I just set a curve number 90. 8.08 acres and a TC of 5 minutes. So that's pretty, when you look at a high density commercial, that's about what you're going to expect. And then the rest of it is offsite. So all of this is all undetained. It's all existing conditions. And this is Dillashaw Pond right here. And that's where it's all draining to. And so the offsite is the large basin 81.4 minus the 8.08. So that's where we're at. The curve number jumps just a little bit because we're taking away some woods and we've got a little bit of imperviousness here, very small amount, but we're basically jumping up the curve number and the time of concentration just in very small increments as we start cutting that offsite basin down and making our developed part of the basin larger. So the pond data. So what I did is I put a pond in for the new commercial in HMS and routed it for the 1 through 100. The volume of the pond was 55,000 cubic feet to route all the storms pre-post. Had a reach in there with all this information I plugged in and ran the model. And what I'm looking at is there's XA, there's the offsite right here. And then there's the, basically I'm bringing it all to a common point where it goes into the pond. So the summary results. Now I'm going to start running through these slides because I got 1 through 100 year events. I want to show you what happens as we progressively increase the watershed with new development. And so here's the first shot. This is 8.0 acres in a developed of a 81 acre subbasin. And what you'll see is I've got the year returns 1 through 100. The pre right here is basically the overall basin pre, the 81 acres. And then the X5A pre represents the 8.08 acres that we're disturbing for the new development, right? Okay, so that's the pre-developed flow rates that we would be matching at the property line. And then we have the post, which is what's coming out of the conventional system to match pre-post. And I did a pretty good job. Thank you. Anyway, so now we have offsite, and offsite is going from 51 to 305. And then the total right here, look at this, just take for instance the 100 year, it actually increased 7% compared to the pre. So it's not like we're blowing the world out, right? It's about 20 CFS, 22 CFS, but that's with 10% developed of the overall basin. Okay, so we've changed the hydrology of the overall basin, but we've just met the pre-post at the property line. So in that respect, we're trying to do one thing, but are we really checking for downstream conditions change? And notice, my pre-developed outlet right here is 41 CFS. All right, and then my post, I matched it at 41. Okay, but 41, and we have 8.08 acres. So multiply that by 10, that's 410 CFS. That's way more than 323, right? So when we do our pre-developed pre-post, and I know we're not talking about homogeneous watersheds a lot when we're in a developed basin, but we need to think about, is our pre-developed flows, is it linear? And with respect to the overall larger subdivision, with the larger subbasin, and you may find that it isn't. And so then we go to a new installment of 8.08 acres, and I'm putting it over here on the other corner of the subbasin. And what's happening here, all this information is going to be predominantly the same. What I am doing here is decreasing my offsite and changing my curve numbers and time of concentrations. And yeah, and there's the HMS model. Same thing with the conventional system, got the reach. And so now here's my summary results by adding collectively the two 16 acres together. Now my peak flows are going from, here they are at the total. This is total at the outlet. We've increased 100-year by 9%. So we're adding on a little bit more pre-developed or a little bit more post-developed flows as we increase the imperviousness of the area. So we add another one in here. Here's the third one that we add in. And there again, pretty much the same hydrologic data that I've used. Offsite gets a little bit smaller, curve numbers gets a little bit higher, time of concentrations gets a little lower, which means more flow. And same, this is a repeat, but the reach is different. Every reach that I've done, I've actually calculated it on LiDAR topo and got all this information. So every reach is common to the subbasin that I'm developing. So here we go. Now we're going up to 17% exceedance of the pre by adding 28% imperviousness. Okay. And so, you know, but we're still matching pre-post at the property line. And so, you know, as we move forward and we add another one, so this one's in the middle there, basically using the same pre-developed hydrology, which is kind of conservative because that's open space, but I'm using the woods. So I'm still using the same, I'm using conservative estimates on my pre-developed flows or hydrology to get my pre-developed flows. My hydrology data stays the same for the post, and then my offsite drops a little bit more. And so does my time of concentration, and my weighted curve number goes up. So when I do that, now I have 4 of them collectively in the basin. Got to reach for it, and my flows now have jumped to almost 20%. So we're going from a 100-year on a 323 to a 384. And notice what's kind of interesting. I really don't know why, but what's interesting is that, you know, somewhere around the 5 and the 10 year is not really that bad. The 1 and 2 year, it kind of starts jumping back up. And the 25, 50, and 100, obviously they get larger. But as we're developing the property, and as that new development continues to build through this overall subbasin that was at one time rural, we got flows that are increasing pretty, you know, up to 50 CFS right now. So now we add another one. And so then I add the reach for it. And so now I'm up over 20%. At what's that, about almost 70 CFS more. So you know, it's kind of like, what are we, does it make sense that we're adding new development, we're matching pre-post at the property line, but, you know, way downstream at an outlet point, we could be increasing our flows. And that's really what I've hit at this point in time, is showing that even though this basin is, you know, I go back to, yes, it's homogeneous, and yes, it's undeveloped, and timing plays a very important key to a lot of our pre-developed and post-developed flows, and how those flows are transcended down to a common outlet further downstream. And it's all a part of your timing as well as your development. So this is the last one that I did. So I didn't want to bore you too much by putting the whole sub-basin in development. But so this is the 6th one. added it there at the right side. And curve number now for the offsite is almost 70. We have a time of concentration. The original TC, I think, was 21 minutes. So now we're down to 13.8 minutes for what's remaining, which is this area right here. So when we do that, we have a reach associated with the last segment. Now we're at 30%, which means we're jumping up almost 100 CFS difference on the 100 year, going from a 323 pre to a 420 post. So we've increased just by adding 51% imperviousness to the basin. We're at 30% increase of our pre-development flows, even after adding detention for the 1 through 100 year events. So then I went a step further and wanted to see what's going on right here at Dillashaw Branch, which is that pond, that existing pond right here. And these flows are basically the inflow to the pond itself, that from the overall larger basins plus our basin right here. So there's a timing mechanism between the two, right? So interestingly enough, start at the 100 year, the pre is 1367 and the post actually dropped, which is pretty neat. And I think what's happening is that with the increase of imperviousness, they're basically, the smaller basins are beating the peak out for the overall 1.6 square miles or whatever it is. So they're beating the flows out, so it's not getting as high. But when you look at the smaller year storms, you'll see that the post is actually exceeding the pre. Is it a lot? No, it's not a whole lot. It's 22%. And then it drops down. So it's kind of interesting to see when you take an overall, a large 2.3 square mile basin and slice it up into different areas, sub-basins, and see what's happening. And there's some folks on chat. Does anybody have a question so far?
Yeah, John, we've got one question, I think, and one comment. First, William, with what are the differences between detention and retention ponds, if any, and what are the situations we use retention versus detention?
Yeah, that's a good question. So retention ponds are essentially a pond that stays wet for an extended long period of time. Think about like a lake that has fish in it. That's a retention pond because it always holds water. And the outlet to the pond is above the bottom of the pond. So basically you have a bowl, and the outlet's above the bottom of the bowl. So everything below the outlet is retained in the pond for, unless it is removed by infiltration or evaporation. So basically that's a retention pond. And every retention pond has some amount of attenuation whenever it's getting rainfall coming into it. It may be very insignificant, but they do have a function in retention plus a little bit of detention. Now, a detention pond is normally a dry pond. That's where the outlet to the pond is dry, is at the bottom of the pond. And so the pond stays dry. Everything that comes into the pond, the runoff, goes out of the pond. But its primary function is to reduce the peak flows that are coming into the pond to flows that are acceptable to downstream conditions. So the detention pond works more for flood control, flood prevention, whereas retention ponds are more for probably like water quality. We have a lot of water quality regulations that are out now where you've got to hold back the 1 inch or 1.2 inch, depending on where you're at, and do a slow release. Sometimes you use a stormwater pond in those designs to where you hold a permanent pool And it never really drains, but it's used for water quality purposes.
Thanks, John. And then I think we have a comment from Jeff Mueller with the city of Tucker. I think it is if the 5s and 10s are performing better, it's probably because of how your detention facility outlet is designed. I think that's more of a comment for you, John, if you have anything to add there.
Yeah, so that's probably a good point, because if you look at here, my 2 and my 5, I'm really matching my 10 and my 5 here, excuse me. I'm reducing the peak flow out more than I am of the other storms. So I'm kind of over detaining for those. So Jeff, that's a great catch, man. I didn't even think about that, but that makes sense. You know, that's the thing about hydrology. You know, I hear a lot of people calling it the black box, you know. Well, it's a model, but you still doesn't mean that you shouldn't be able to look at your results and say, do these make sense or not? And Jeff, you hit a good point. Yeah, that makes sense, because I'm over detaining for the 10 and the 5-year events. So naturally, we're going to reduce those rates in the overall basins as well. So this is that it, Russ? Do we have any more questions?
Yes, sir. That's it for now. And
okay.
You have about 15 to 20 minutes of content time remaining here.
Good. So this is a little graph that I did to show the similarities between let's start right here. This is highly developed, where I used all 6 of the commercial sites together, and I did a chart graph, and I had percent exceedance in comparison to the return year. And so this is what Jeff pointed out. There's over detention in this area of the chart, which is why we're seeing a drop right here, and it jumps back up. And so what you're seeing here the green line represents that A through F subbasins. And so we're seeing it gets up to 30%, anywhere, you know, from 50 year on, over 30. And then we have a little bit of a decrease. And then what I did at the very end was plot Dillashaw, basically that outlet, and showed its significant of exceedance in comparison to the year event. And you can see that for the smaller storms, it seems to be have less of or has more of an exceedance in the smaller storms than it does the larger storms. So let's see here. All right, so what I did after this was look at what can we do if we inserted what our device does, which is the automated, and I misspelt that, so sorry, I became engineer. Automated outlet structure, we call it the AOS, but essentially it's a robotic outlet control structure that uses rainfall, which up here's a rain gauge, and it's collecting rainfall out of the sky. Solar panel is power, is off the grid, power provided. And we have 2 types of units. We have a vertical unit and we have a horizontal unit. And they all normally go inside a concrete box. And this one's mounted to a baffle wall. And so what happens is when it rains, the rain gauge picks up the data, the rainfall information, sends it to our onboard processor, which kind of like is your hydrology program, if you will. And it's using the curve number equation and the SCS unit hydrograph to come up with what the pre-developed flows were based on the amount of rainfall that's coming out of the sky. So it applies that information to determine how much water can be discharged from the pond, so that we are sort of like matching the pre-developed flow rate. So our system can match the pre-developed hydrograph from start to finish. And then we also can as an option, just do straight up attenuation for the regulatory storms. So in this case, I just compared using our AOS to the conventional structure for the 1 through 100 year events, and went back through the model. And essentially what I'm doing is setting the, I'm including the pre-developed peak flows that I can release in right here at my 8.08 acres. Okay, that's my allowable release. But at the outlet here, I can't exceed my 323. So what I have in the model, in the model itself, is I've got two watersheds going. I have the pre-developed watershed and I have the offsite watershed going. So basically what I'm doing is I'm subtracting out I'm subtracting out of my pre-developed watershed of my offsite to release what I'm allowed to release, but I check it against what my pre-developed flow rate is at the property line. So if I didn't use my pre-developed flows as a second condition for meeting compliance, then I could be exceeding the pre at the property line, but not exceeding the pre down at the 80 acre point of analysis. So I have two checks. I have one at the property line, and I have one downstream. And so what I'm doing essentially is summing up, as you could expect, summing up the ordinances of the hydrographs and coming up with what I can release at the peak. And so this is the peak release rates from the pond using an AOS. And see, I'm over detaining a little bit so that I am still matching the 323 at the outlet. And I needed 56,000 cubic feet for pond 1 to do that. The conventional system needed 55,000 cubic feet of storage to route the 1 through 100 year events at the property line. So we're pretty close, right? And this is the hydrograph of our AOS. And we'll start out with the blue. The blue represents the release rates from the pond. And notice that it is not a smooth hydrograph like you normally see with an outlet control structure. That's because it is choking down the gate, it's choking down the gate to reduce the flow out of the pond when it's including the offsite, when it's checking for the offsite bypass. So we're basically checking the year storm, checking the bypass from that year storm, and then we're saying, okay, how much can I release from the pond at an overall perspective regionally? But then, okay, this is my number, but then checking it again against the pre-developed 8 acre site to make sure I'm not exceeding that. And so the hydrograph gets a little bouncy right there. The red right here represents the inflow into the pond from the commercial development. And the green represents the pre-developed flow for the overall 41 acre watershed. And then the red is the total, which is the combination of the outlet from the pond plus the bypass based on one AOS, one 8.08 acre development. And so we're matching the pre, and we have FYI, but we implement a recession algorithm to where when we're able to, we can match or closely match the recession side of the pre-developed hydrograph so that we don't continue to release flows like you normally would kind of expect from regular detention, and which has a effect to downstream conditions by delayed release. So all that said, and we're matching the 323 for the overall pre there. So then I add another pond, same thing, same storage volume pretty much. So now we have 2 AOSs in the overall 81 acres. And this is the output for the 100 year event. And same thing is the AOS release at the bottom, and we're matching the pre-developed flows at the top. Then we add another one, and now this one required more storage volume. So there's, so as you develop, what we're seeing, I think the conventional system was 54,000, we're at 66,000, which is more than what the conventional is, but the conventional still wasn't doing its job either, right? So yeah, in certain instances here we are needing add more volume to control the overall pre-developed peak of the larger basin. But
hey, John.
Yes.
Yeah, if I could, we've got several questions, but I feel like one of them, if we could answer that now, it'll help add some content as you move forward here. From Brad Horrible at Kinley Horn. Is the automated control structure at the commercial site pond or at the Dishaw pond?
At each commercial site.
Each commercial site. I think
Yes.
That'll help as we move forward here, just to answer that one question.
Yes,
I'll hold the rest for a bit here. Thanks.
So yes, that's a good question. I probably didn't explain that well, but for every 8.808 acres we're adding to the overall watershed, we have one pond for each one of those developments, and collectively they release to the Dillashaw outlet. Okay, so what I did originally was go through a conventional system for each pond, and now I'm going through the AOS, or replacing that conventional with an AOS at each development point. And there's somebody that asked about I saw Opti system. Where was that at?
Yes, Kevin Middlebrooks with Gwinnett County had asked, does the AOS rely on a cloud-based operating system similar to Optic RTC? If so, is there an annual fee for service?
One thing I want to stress and point out is that everything that our system does is on site. It's using on-site controls, on-site sensors, on-site programming to make its decisions. The AOS does have two-way communication. So for instance, back in the beginning, I was telling you about Joe Tucker Pond in Helena. That system uses forecasting. Basically, we reach out to a weather API system and we get the forecast for the next 6 hours, okay? And so on Joe Tucker, for instance, I know from studying the hydrology or the watershed model that if I drain the pond before 2 inches of rain, I can retain that full volume of runoff. So 2 inches of rain over 1 square mile requires about 2 feet of water surface storage drop in the pond. But it does not, our AOS does not depend on offsite cloud data to do its job. And so I like to make that clear, because there is going to be a time where the communication is not there, whether it's bad weather or for whatever reason. Our AOS operates off of 5G LTM cellular, okay? So, and it transmits everything that it's doing back to our website so you can view it. And then if there's ever a time where you need emergency override, you can always use your phone to override a gate opening, or you can see that, oh, the forecast blew itself. We're supposed to have got 3 inches of rain, now we're getting nothing. And so instead of having a dry pond, you can close the gate and override that part of the program so that you can save your water. And that's one thing I like to stress out, is that forecasting is what it is. It's as good of a check as we can do into the future. But is it always right? No, it's not, especially around here where we can have pop-up showers. And I always check my weather app. It always gives me the inches every 6 hours, and the inches of rain, just like yesterday. I don't know anybody around Birmingham, but Vestavia Hills got 3 inches of rain in like, I don't know, 20, 30 minutes. It was a nasty storm that just popped up out of nowhere. But the forecast models didn't show any of that. Okay, so forecasting is great, but it does have its limitations. That's why we continue to use real on-site hydrology to control our flows out of the pond and have that override, remote manual override, if you will, to override instances where forecasting might not be accurate.
Thanks, John. Just a heads up, we have 10 minutes left till the conclusion of the presentation. I think you have a little bit more technical content you wanted to get through, so I'll pause on the questions for there. And
yeah, there is one here. What is the automated control structure fails? Is there an emergency overflow? Every AOS has an internal baffle wall. And if it's just like if you're designing a detention pond with the outlet control structure, whatever it may be, you have an emergency spillway, because there will be a time in any outlet control where you get a log or you get Johnny's baseball stuck in the hole, right? And so then it clogs it up, especially with these water quality orifices that are designed for 2-inch diameter. Great opportunity for a golf ball, right? To make a good spot and a good new home and an opening for a water quality orifice. And that's what makes our AOS a little bit different too, is because it uses the gates as a weir to open and close. And so we don't have these small little holes anymore to control low flow water quality release rates. But that's a good question. Okay. So yes, and are we working with jurisdictions to ensure they approve the AOS? Yes, everywhere we go, if we have not met with the city and we don't have a system in with the city, we go and do a presentation, a demonstration of our system, show it to them, and we have not been denied an application of our AOS in any jurisdictions. Now, there are some jurisdictions, like for instance, Gwinnett County requires us to submit an application for our AOS system. And we're in the process of doing that right now. So I'm gonna finish up here real quick because I've got 3 minutes. And so here we are, long story short, by adding the AOS to the rest of the ponds, A through F, I'm showing basically the results. So here's the 5th pond. We're still doing the same thing, a little bit more storage volume required. Printout of the 100-year hydrograph. And then that reversed. But so what I did was I ran the year events down at Dillashaw Pond with the AOS, and that bottom graph right there basically shows what our AOS release, what the overall release rates are at Dillashaw Pond using the AOS. And yeah, I've already shown the conventional one. But the 6th pond, I basically show 67,600 cubic feet of storage required. The AOS would be a 33-inch by 24-inch rectangular weir, if you will. And that's what would be going in each one of those 6 ponds to control the flows of the watershed. Final hydrograph. Oh, and notice something here real quick. Down on this hydrograph, you'll see right here where I'm circling with my mouse, the AOS basically is closing down to almost nothing right here, so that we are not contributing or increasing the overall downstream peak. So with a conventional structure, we couldn't do that, right? Because there's water in the pond and it's going to release out what it has to release based on that head. So you have one option really, and that is to make a larger pond so that you can chop off the peak flows from the regular outlet control structure enough to not influence the overall downstream basin peak. I wish I had more time to talk about, but I can't. But you know, the finals here, takeaways is that every project that we work on, and I've worked on several of them, we're recreating again and over the overall basin watershed. If we have to check for the 10% or we're going on downstream. So if you're in a regulatory, they say, well, you need to check 10%. Well, your neighbor may have just built a Publix, and he did his 10%. Now you've got to, and you're in an out parcel, and you got to do your 10%. So are they even going to match? That's a big question. The other thing is that some engineers may not even realize that there's new development going in permits that are going to be applied to that same watershed. So your calculations are not going to include that development, right? And then newer developments. If I get a new project, I go to Google Maps and I look at what's existing in the overall basin watershed, and that's my existing conditions. But is that what it was 10 years ago? So as we build out these watersheds, these larger regional watersheds, what's existing conditions makes a big influence on how our effect is downstream regionally. And so, and also, a lot of conveyance systems don't have the capacity to convey the 100-year events or the 50-year events, or some even the 25, depending on how old they are. So you've got, there's other things that we may need to do and to create a higher level of stormwater management, if you will. And I would think that it would start something by just looking at taking a watershed area, maybe it's your MS4 outlet, and creating like a zoning map, how we do for commercial developments or for comprehensive zoning plans. We make a watershed map and we designate specific outlet points in the watershed to hold our pre-post flows and the timing too, so that we're not affecting these watersheds with new development as they come in. Then just develop a basin model, just like I did for the 1.6 acre, that would represent the existing conditions. And then as new development comes in for permitting, the engineer would submit basically their CAD file, their hydro package, and all that can be inserted into into the CAD file. and then we can insert it into the overall basin model, and we can recreate or rerun those new conditions and verify that the points of outlet that we're concerned about are not being altered by the new development. So that's it. I hope y'all enjoyed it. I was 2 minutes over.
No, that's great, Jon. There's a lot of great content there. Congratulations on your efforts. FloodCon is only a few years old, 5, 6 years old, I guess, this year in 2023. You've achieved a lot. I understand that doesn't go with a lot of blood, sweat, and tears, of course, hard work. And I know you've had sacrifice to make that happen. So congratulations to you. I do know that, you have the OS patented in the United States and Canada in over 100 systems in the Southeast. Your little case study was very informative. We got a lot of questions coming out of that. That was clearly in the state of Alabama. Can you tell us what states you're working in the Southeast and currently deployed?
So we're in North Carolina, South Carolina, Tennessee. That's including Nashville, Knoxville, and Chattanooga. We are in Georgia. We are in Ohio, and we are, let's see, of course, Alabama. And golly, did I miss one?
That's great.
So we have systems. We have other monitoring systems in Maine and Florida. We're working on a project right now in Tallahassee, Florida, for an AOS system. So we're diving into that new jurisdiction.
That's
There
great.
is a question here. I know we're running out of time. But
that's great, Jon. I was going to conclude here. We don't have much time to wrap up. I apologize. There are several questions because your content was so great. What I want to do after we get off, I'm going to connect Jon with the remaining questions that were asked. I do apologize. We have this problem with all great presentations running out of time. Jon, in closing, We do have 3 gift card winners, courtesy of United Consulting, and I'm going to announce those. And then Jody with my team will reach out to you. We've got Kevin Sharp with Gaskin LaCroix, got John Harpering with PEC, and Brett Buckland with Bowler Engineering. So thank you all, and congratulations to our winners. And with that, I'll pause there. John, how can folks get in touch with you? Your phone number and email.
Yes. Phone number is area code 205-807-1799. I had it posted. So will everybody, Russ, will everybody get a copy of the presentation?
Yes, we can share that with the team.
Okay,
no
it was
problem.
on the last screen of the presentation.
Yep.
And so it's that if you
Right.
can see it. So
Perfect.
yeah, we're in Homewood, Alabama, right off the interstate, but please feel free to give us a call, email, whatnot.
Very good. Thank you, John. Great job. Excellent content. And thanks everyone for joining us. Hope you take something home of value for yourself, your business, and your clients. Everybody have a great day. Thanks now.
Thanks, Russ.